Miss Barbara.
Hello, Mercedes. Okay, so we'll get started on what we'll discuss. And as I said, we'll go over the homework that had exponents, radicals, and probability. And we will actually go back over what we went over because I'm not, well, I'm sure you're really not understanding some of this. Get, we probably won't discuss probability other than the homework, but we will concentrate on scientific notation and simplifying radical expressions. Okay, so let's go to our homework. And thank you for sending the homework. Thank you for trying it. Okay, that's the wrong homework. Let me go new share. And I want, oh boy, let's see. Share topics. Uh, hold on a minute. Let me bring up the one that
We're going back to 14.
yeah, I know. I have 14. I want 11. Okay, let's see. I may have, okay, let's see. Okay, let me bring up the one I need here. Hold on with just a minute. I've got to bring in the, because I was working on the one for the next time because I changed it because after I graded your papers, I realized we needed to go through something else. Okay, let me go back. I hope I can bring this up. Let's see. 11. And okay. New share. Okay. Can you see 7-Eleven?
Yeah.
Yes.
Okay. All right. All right. So this, we're going over the homework that I assigned to you. Now, I think you both had this one correct. I sent you back what you had correct.
Oh, maybe I was sleepy when you sent me.
Well, I emailed it back. Well, I recorded it. Let me just look here. We'll go over it anyway because I told Alba she had something else and I told I was recording it, so we'll go over it anyway. Okay, so, but she had that one correct. Mercedes, you had it correct. Maureen, you didn't send me answers. What happened?
No.
Your hand was bothering you?
Yeah,
Mhm.
I had allergies by
Yeah. So you want to tell me what the answer is for this one? How do you write 8.317 times 10 to the 6 in standard form? What is your answer,
I
Maureen?
put D for my answer.
Okay, that is correct. Answer D, because your decimal point is behind this last zero, right? And when you move it 6 places to the left, you know your exponent will be positive. So that's 3, 6, and it's between the 8 and the 3. So 8.317 times 10 to the 6. All right. So Mercedes, no questions because you have that one correct, right?
Yes.
Okay. Let's go to number 2. Now, that was a true or false. Scientific notation is made up of 2 number parts. The first part should be a number between 1 and 100. And let's see, you now,
I put
Mercedes
false.
said false. You said false, and that is
Yeah.
correct. It should be a number between 1 and 10.
Yes.
All right, you had that one right, Mercedes. Good.
Yeah.
And I had it. Alva had true. So no, the 100 makes it wrong. It should be between 1 and 10. Okay, so the answer
Mm,
is false, B. I think I told you less than 10, but it
Yeah.
should be between 1 and 10. In other words, you would not have a decimal in the first part of your scientific notation. In other words, like up here, you wouldn't have 0.83. All right. It has to be between 1 or greater, but less than 10. All right. Okay, let's go to number 3. And number 3, now Mercedes, you said C. Why did you say C?
I was a bit doubtful. I wasn't so sure.
Okay, read number 3, Mercedes.
It says, how do you write minus 5.6 times 10 to the minus third power in instead in the standard form, sorry.
Okay, in standard form. Okay, so now you're translating scientific notation to standard form, and it's a negative, right? So you'll be shifting your decimal point. Which direction, Mercedes?
To the right. To the
No,
right.
no, negative. You shift into the left,
Yes, yes, the left.
right? The
Why I was
left.
unsure. So I just
Okay.
grab a
Well, you shifted to the left. The only thing is you threw away your negative.
oh yeah.
Well, if it says negative here, it has to say negative in standard form.
Oh, see. Oh yeah, I choose
The one you chose did not have a negative, but you said C.
it's
C
D.
is a positive. Let me ask Maureen. Maureen, what's the answer?
I put B, but I'm sure.
You put what?
B as in boy.
B as in boy?
Yeah.
No, it can't be 5,600. It has to be
Oh,
a number less than 1. Remember, if it's a negative exponent, the
Oh,
standard forms has to be a number less than 1.
oh,
not Mrs. D.
That's right. Because there's your negative. You shift to the right. 1, 2, 3. And there's your minus 3. Got it?
I didn't, yeah, but I didn't have minus this.
Maureen, why did you say B?
Because that yours person had minus.
No, but what the exponent, if it's a minus, if the exponent is minus, then your number has to be greater than 1,
Oh, I see.
right? So it can't, 5,600, Mercedes, what would this number be in scientific notation? Tell me, what would it be?
This one.
B choice. Give me the scientific notation for choice B.
Okay, it will be 5
Don't
point.
throw away your negative.
Then the sign
It will be negative what?
5.6.
That's right. And that's your first part. And
And
10 would be the what power?
third power.
That's right, because you move your decimal point how many places? 3 places. Okay, there you go. See, Maureen, that would be a +3. And this is a -3, right? So that would not be correct. So the answer again, what's the answer, Mercedes?
D.
Answer D. You got it, Maureen?
Yeah.
Okay. So, because you can't have what you said because that number is too big. Your number is less than 1. This number is 5,600 minus 5.6 times 10 to the +3, which is different from minus 5.6 times 10 to the -3. Okay, now number 4. Okay, Mercedes, you had that one correct. So, Maureen, which of the following is the correct scientific notation? What's the answer?
I had, let's see. Oh, I didn't do that.
Okay, well, do it. Tell me which one is correct. Which choice is correct for scientific notation?
Is C?
No, because the first part should be between 1 and
And
10. So
Oh.
which number, the first part is between 1 and 10?
D?
D, that's right, D. Because 20.35A, that's too big. 0.2035, that's too small because it has to be between 1 and 10. 2035 is too big. 2.035, that satisfies the first number, the first part of the scientific notation being between 1 and 10. So the answer is D. So Mercedes, you had that one correct. All right.
Thank
And so did Alpha had that one correct. Okay. Now, Mercedes, read number 5, please.
Number 5 says the US spend an average of 1.02 times 10. Sorry, let me reread. 1.02 times 10 to the fourth power dollars on each student per year. There are about 7.6 times 10 to the 7th power student in the US. About how much money total is spent on student per year?
Now you said C. Now, how do you, let me ask you, Mercedes, you just read this. How would you calculate the money total spent on all the students per year? What operation would that be?
Miss, you want to know the truth about this one, Miss?
Mhm.
I just guessed an answer. I couldn't even get to work it out.
Okay, let's let Maureen help you
I-
out. Maureen,
I didn't do that.
no, I didn't ask you that. I want you to tell me what, after Mercedes read it, you've read it, what operation would you do? What mathematical operation to find the money total?
You multiply?
You multiply, that's right, because you know how much for each student was spent and you know how many students. So you have to multiply this amount. That's for one student, right? And the 7.6 times 10, 7, that's the total students, right? Mercedes, you follow? If you-
Can you read that? Yeah, you're reading what's the you're reading the facts? Sorry, I just missed it a little bit.
Okay, you spend an average of 1.02 times 10 to the fourth dollars on just one student, right? That's what the each mean. There are 7.6 times 10 to the 7 students. To find the
Oh,
total you spend on all the students, you have to multiply the number of total students times the amount you spend for one student.
oh,
You got it?
yes.
So you take this 102 times 10 to the fourth, let's copy that, and multiply. And Maureen, I want you and Mercedes to multiply that. Okay, multiply it by the 7.6. Tell me what you get. Okay,
Multiply that. But
multiply the 1.02 times 10 to the 4 times the 7.6 times 10 to the 7th. So let's just put that there.
okay.
Multiply that out and tell me what you get.
I said I remember how to do the power on my calculator. I'm not doing that often enough to remember.
Okay.
How to do the power on my calculator?
Well,
I get,
you have to add the powers.
I get,
Multiplications, add the powers. What did you get, Maureen?
okay,
Okay.
So first you multiply the first part.
yeah, I get
1.02 times 7.6. What did you get,
I
Maureen?
get 7.752 to the power 11.
Okay, you got 7.7. Well, I don't want the power just yet. I just want
Okay,
the number. You got
okay,
7
7.
point,
Uh-huh.
keep going. 7 point
7,
what?
7.752.
Okay, that's what you got from multiplying the
Uh-huh.
first part, the
Yeah.
10.02 times the 7.6. All right,
I got
Mercedes, you follow?
I got 775.2. Maybe I put it in wrong.
Or you
You
probably put
put
the point wrong there.
1.02 times 7.6. Do it again, Mercedes. 1.02
One
times 7.6.
four time. Oh,
7.6.
oh, okay. I said it in wrong.
Yeah,
No, I
because it's
got
got to be just slightly over. It's got to be over 7, but not 777. That's too big. So what did you get, Mercedes?
I got 7.752.
Okay. All
And
right. Now, when you multiplying scientific notation or just exponents, period, what do you do to the exponents, Mercedes? What's the rule?
you add them
You add them. So this will be 10 to the what power?
to 11th power.
That's right. 4 plus 7 gives you 11. So this would be 11. And what answer is that, Maureen?
Yeah.
A. That's right. That's your answer.
I said, Miss, I look at C and I look at A. I look at C, but I don't have any time. Because I start doing them at work. So when I came in, before I sleep, I have to send it to Miss Barber. So I say, you know what, I just guess the answer. But I was looking at A and I'm looking at C. I says, I know it's one of them. What I was,
Yeah, but you didn't multiply the
no,
1.02 times the 7.6.
no, I just guess an answer because I was hurrying to say anything before I start falling asleep.
Well, at least you recognize that you had to add the powers
Yeah.
in for the multiplication. But then if you had quickly done the multiplication, you would have got the 7.752 and you would
All
have
right.
had your answer, right?
Honestly, I wouldn't get it right. Why? Because I didn't know that I should just put in 1.02 times 7.6. I would be
Yeah.
putting the time 10 every time.
No. What you do when you have a scientific notation calculation, do the first part first and
Oh,
then do the exponents.
okay.
All
Okay.
right. So if this had been a division, you do the division of the first part first, and then you follow your rule of exponents to do the second part, the 10 to
I
a power.
I think that's the reason why I didn't even try to multiply because I figured it was multiplication to see the amount, you
Yeah,
know,
but it's a lot easier if you just pull out the first part and multiply it, right?
because it's the first I'm seeing like this set out to multiply.
Okay.
I was sure I would have to leave 10 or
hmm
not.
hmm No,
Next time.
well,
uh,
whenever you have scientific notation operations, do the first part first and then do the exponents.
Okay, thank
So this
you.
will be 1.02 times 7.6, and that would be 7.7. Let me just write it here. Okay. Okay. So when you have something like this, do the 1.02, that's my 0.02 times 7.6. All right.
Okay.
And you have that answer. And that's let's see back, that's a parenthesis. Okay. So that you got the 7.752, and you, Maureen told us that also, 752. You've got that, right? And then then you can take the tens to the power. So that's 10 to the fourth. We just put the fourth power there, right? And let's just put it in parentheses. And then we have 10 to the 7, right?
Okay.
And let's just put that in parentheses. And what's that equal to, Mercedes?
10
10,
to 7th power.
10 to the fourth
No.
plus, no, we add the
Oh,
powers.
oh, oh, you put them on first.
Yeah.
I thought I was going to do that first, miss, instead of.
Yeah, I'm putting it here because remember, I'm recording this and Alba has to look
Oh,
at this, and whoever else might want to look at it. All right, so I'm just putting it here, just what we are doing. Make it really clear.
okay.
All
Thank
right,
you.
so you do it in two parts. Part 1, take the first part of the scientific notation, do whatever operation, the same for division, right? And then do the exponents, then you put them together and you have the answer, 7.752 times 10 to the 11. Got
Great.
it?
Yes, thank you.
Questions? Maureen, you okay?
Hey, okay.
All right. All right, let's go to number 6. Rationalize and simplify. Now, Maureen, you remember what we said about rationalization? How do you rationalize?
I remember, yeah.
Mercedes, you remember?
Recognize this.
Um,
How do you we're rationalizing just the denominator here. So how do we do that? You remember what we said?
we try to find there's a word to call it again. Um, find the numbers that can go into. I don't remember the mathematical term.
What are we trying to find?
The number that can go into 6. Um, correct. What is it? I don't remember the name of the mathematical terms.
No, we multiply by the radical in the denominator, and we multiply that by the top expression and the bottom expression. In other words, by the numerator and the denominator. All right.
You're saying we multiply by,
The radical that's in the denominator.
yeah.
You multiply both the numerator and the denominator by the radical in the denominator.
Okay.
Right?
Yeah.
So that means we put a square root of 3 over a square root of 3. Okay, so let's put that there because it's always a radical that's in the denominator. So we put the radical here, and I'll just put underline here because we're multiplying both the numerator and the denominator by that radical. And then we put our square root of 3 here. That's the first step. Questions on that first step?
So the first step is to multiply denominator and
The numerator and the denominator by the radical that's in the denominator. And that radical is square root of 3.
okay.
Okay, that's the first step. Questions on the first step? Question, Mercedes?
No, miss. Sorry.
Okay, so we'll multiply the numerator, which is 6 times square root of 2. We multiply that by square root of 3, the radical. That's the radical right there in the denominator. Now, notice I'm saying radical, but I'm referring to both the radicand and the radical symbol. Okay, because
Okay.
the radical is made up of the radical symbol right there and the radicand that's under the radical symbol. All right. Now, when we multiply this out, okay, what do we get for the top number? I'll say these.
9.
How
No,
do you
sorry,
get
sorry,
9?
sorry. 3. The radicand.
No.
Oh, I'm mixing it up again. Why can't I get this one?
When you multiply 6 times the square root of 2 times the square root of 3, what do you get in the numerator? What do I get here?
When I multiply 6 by 3, 18.
No, no, one is on the radical, one is not. You can't do that. That's a no-no.
Oh,
They have to all be either numbers not on the radical or number on the radical. So what do I get? Maureen, you know what I'll get here?
6.
Okay, 6. And what else?
Uh, 6 square root 6.
6 square root of 6. Because square root of 2 times square root of 3 is square root of 6. So I'll just take the square root of 3 and put it here and then put a 6. Mercedes, you follow?
I'm trying to miss. I don't know why I'm not getting this radical.
Okay, here we go right here. Now that's a 6. See, you can multiply a radical times a radical. So 6 is just remains 6. That's like a coefficient. And square root of 2 times square root of 3 is square root of 2 times 3. That's how we got the 6. Got it?
Okay.
Questions?
No, miss. But
Okay.
it's not finished, though, miss.
No, we're not finished. Now, what did I say when you multiply radical times same radical? What do you get?
You get the radicand.
Radicand. So what is that, Mercedes?
6.
Square root of 3 times square root of 3.
Oh, 3.
3, that's right. That's the radicand, the number under the radical symbol. That's a 3. Anytime you multiply radical times same radical, you get the radicand. Remember, square root of 10 times square root of 10 is 10. Square root of 1,000 times square root of 1,000 is just 1,000. So square root of 3 times square root of 3 is just 3.
Okay.
Okay, now, Maureen, how do we simplify this? We've gotten rid of we've made our radical in our denominator a rational number of 3. But I said rationalize and simplify. So do you see a way we could simplify this expression?
I divided 3 into 6.
Yes, divide 3 into 6, because 3 is a factor of 6 and it's a factor of 3. So let's just copy this, put it here, and put the 3, and you said divide by 3. So 6 divided by 3 is what, Maureen?
2.
2. So that then we repeat our square root of 6. We didn't touch that. Okay. There. And 3 divided by 3 is what? Maureen.
1. Sorry.
Maureen, 3 divided by 3?
It's 1.
1, that's right. So what's your answer? Maureen, what's your answer?
Let's see.
Oh,
D.
What is it?
D.
D is in dog?
Yeah.
That's not, this is
No.
your answer right here.
C.
No. Your answer is 2 times the square root of 6. So what answer is that, Maureen?
B.
B. That's your answer. So answer B. Mercedes, you follow?
Yes, ma'am. I'm trying to get it clear in my head.
Okay, we'll go back over it.
Put it on up.
Okay. So that would be, let me just put the answer here. Answer B. All right, let's go back over it. First step is what, Mercedes? You want to repeat what I said was the first step?
First step.
In rationalizing the denominator. In other words, changing the radical in the denominator to a rational number. And we have a radical square root of 3 in the denominator. So what was your first step?
Change it to a radical number.
No. Rationalize, and we'll rationalize the denominator. What
Okay.
that means is take your radical in your denominator and make it a rational number that is without the radical. So what is your first step? It's right here. What is that first step?
So that your to have radical 3 on upon radical 3,
What's
like
the operation?
division.
No, this is multiplication.
Oh, because I see. Oh, yes, it is sign.
Yeah, you're multiplying both the numerator, 6 times square root of 2, and the denominator, square root of 3, by the radical square root of 3.
Okay.
Got it? What did I
Yeah.
just say, Mercedes?
I'm not quite sure. I don't know where I'm not getting it. You says that. Oh,
You're rationalizing the denominator. You're trying to make this denominator, square root of 3, just a rational number.
so
All
I'm
right?
trying to make the square root of 3 become a rational number.
Yeah, you're going from radical square root of 3 to rational number 3. To do that, you multiply the square root of 3 by the square root of 3. But when you multiply both numerator and denominator by, that's like multiply by 1, and that's permissible. You can take an expression and multiply it by 1, right?
Okay.
Square root of 3 over square root of 3 is 1. So square root of 3 times the numerator gives you 6. That's a coefficient. The square root of 2 times square root of 3 is square root of 6, because you can multiply numbers that's under the radical, right?
Okay.
And then when you multiply the, excuse me, when you multiply the radical 3 by itself, you just get the radicand. That's the number under the radical, and that's 3.
Okay.
Got it? So now we are left with 6 times square root of 6 over 3. But
Okay.
since I said simplify, Maureen said, well, we can take 3 into 6, because 6 and 3 both can be divided by 3.
Yes.
So 6 divided by 3 is 2. 3 divided by 3 is 1. And any number over 1 is just, or expression over 1 is just the expression. So that's 2 times square root of 6. That matches B, choice B. You got it?
Yes. I'm gonna that the same one. I'm gonna read it over again. But sometimes I get what you're trying to say now.
Right.
Because every time
So,
I thought one and I look at it, I say, "Oh my God, what should I do next again?"
so
I don't know.
let me just ask you the question. You give me the answer. So when you're trying to rationalize the denominator, what's your first step, Mercedes?
Is to make the radical become uh let it rationalize the radical.
So what's your first step?
My
What do you do?
my first step is to multiply um multiply the radicand 3.
No,
No,
don't use numbers. This is generalizing now. What's your first step when you're trying to rationalize your denominator? What's your first step?
that is what keeps on slipping me every time. I gotta write it, put it in writing so I can read it. I remember it. Every time I just go blank. It's the first math so long. Even I do
Okay.
so every time
Okay.
it.
Let me just do this.
uh,
Multiply
rational
numerator and denominator by the radical.
Okay.
That's your first step. Multiply numerator and denominator by the radical. Okay. Step one. And sometime when you do that, you finished. But if you have to simplify, you may have a step two. And I'll put here step two.
Simplify.
And yeah, if needed, because sometimes it's already simplified.
Okay.
Okay, so step two is like an option. Sometime after you do step one, it's already simplified.
Okay.
All right. Questions?
No, man.
Okay, let me just give you a one to try. Okay. Okay. Rationalize. Okay. Now let me give you this one. Let's see. 5, and let's make this square root of 2. Let's see, do I want to give you, okay, yeah. I'll give you another 5 times square root of 2. Trying to give, think of one I can give you where you don't have to do anything but rationalize and it's already simplified. Square root of 2, and I want to put that over. Let's see. Okay, square root of 3. Okay. Okay, Maureen, I want you and Mercedes to solve that one. I'll put it all on the next, so you can tell me what to put. Okay, I want you to rationalize this expression. 5 times the square root of 2 over the square root of 3.
square root of 5.
It's 5 times the square root of 2 over the square root of 3. Let's see. What are you going to do first, Maureen?
Multiply the 3 by the 2.
Multiply what?
I will multiply, okay. It's the square root of 5, square root 5 to square root 2, right? So the polynomial is the radical, right?
So what is my first step?
Multiply
Multiply what?
the 2, the radical 2 by 3.
Step 1, multiply numerator and denominator by the
Right.
radicals. Okay.
Right.
So what does that mean? Tell me what to put here.
You got to put the 3 there. Like the 2.
You put the 3 by the 2. What are you throwing away your radicals?
Radical 3.
Yeah, you've got to multiply. Okay, let me just put this here. Okay, and this is multiply. I'm using the asterisk. So what do I multiply this by, Maureen?
3.
What
Radical
that?
3.
Say it again.
Radical 3.
That's right, radical 3. This right here.
Yeah.
Okay, so put this radical 3. And Mercedes, what else do I do?
Multiplied the radical 3 by the 5 too. No, 2 by the 5. Radical 2 by 5. I don't know if I'm saying it right.
No, what's the next step? I mean, well, we're still in the first step. It's something we haven't done. What is that?
We didn't do the 5.
No, remember you're supposed to multiply numerator and denominator.
Yeah.
So what do you need right here?
We need
Radical 3.
5 or
No, what do you need?
another 3.
Radical 3.
Radical 3.
I want you to talk math to me now. Radical 3 and 3 are not the same, right? So you multiply numerator and denominator by radical 3,
Radical 3.
right?
Okay.
You're still gonna have to simplify, but that's okay. I was trying to get one where you didn't have to simplify. Okay, so what do I get for the numerator when I multiply this? I'll say these. What do I get?
You get the radical 3.
What do I get when I multiply 5 times square root of 2 times square root of 3? What is that equal to? My numerator is now what?
You say 5 times 2, 15.
No, you can't multiply a number by a radical. You can multiply a radical by a radical.
Okay, so radical by radical, you're gonna get radical 3.
5 times square root of 2 times square root of 3.
5 times square root of times square root of 3.
What is that equal to?
Is that 10? Radical 10?
No, you can't multiply 5 times square root of 2. One is just a rational number, the other one is a radical. So the 5 stays by itself. Now you can multiply the square root of 2 times the square root of 3. What does that give you?
Say that again?
Square root of 2 times square root of 3 equal what? You can multiply a radical by a radical. And what do you get? What's 2 times 3, Mercedes?
6.
6. So that's going to be radical. Okay, let's put it here. 6. And okay, now what do I have for the denominator, Mercedes?
Radical 3.
Radical 3 times radical 3 gives what?
Radical. Radical 3.
It gives you what?
3.
Just 3. That's right. The radicand. Okay. And now it's simplified, right? Yeah, I was trying to give you one that's already simplified because we can't do anything with the 5 and the 3. That's just 5 times square root of 6 times square root of 3. That would be your answer. I was trying to give you one where you, once you do the rationalizing, it's already simplified. All right. That's your answer. Questions? See, before we had a 6 that wasn't on the radical and a 3, and then we could simplify. But here we have a square root of 6. We can't do anything with the square root of 6 and the 3. Okay.
Okay.
That's your answer. 5 times the square root of 6 times 3. That's as simplified as we can get. So sometimes you
So you're
rationalize
saying,
and it's already simplified when you're done with it. You don't have to take it another step. That's why I said that step 2 was optional.
okay, so Miss, looking at it, begin from the 5 with radical 2 over radical 3. Um, we just we forget about, don't use the 5, just use the first denominator and numerator.
Yeah, but see, you trying to rationalize the denominator, the square root of 3. So you multiply the square root of 3 by the square root of 3 for the denominator. But if you did that for the denominator, you have to do it for the numerator. So that's square root of 3 times 5 times square root of 2. But you can only multiply radicals. So square root of 2 times square root of 3 gives square root of 6. And then the 5 is a coefficient. You just have the 5. Because there's no number there to multiply 5 by. You have to have a number. You can't multiply it by a radical. That's why you leave it as 5 times square root of 6.
Okay, okay. That's where leave the 5.
Yes, just leave the 5. Okay, just a coefficient. It's just like you had 6x. 6 is the coefficient with x being the variable. Here, 5 is the coefficient with square root of 6 being, we'll say, a variable. Okay.
Okay, okay. So
So,
getting understanding now.
all right. So now this is one we rationalized and it was already simplified once we rationalized. So we leave it. That's the answer.
Okay.
Question, Maureen, you okay? You clear on
Yeah,
this?
yeah.
Okay. So we took you through step 1. Let's go back up here. Multiply numerator and denominator by the radical. And we did that. And step 2 is if needed, but we didn't need it because it's already simplified. Got it?
Yes, miss.
Any questions on rationalizing? Okay, now we go to simplifying. Simplify the following expression. That's number 7. Let's see, Mercedes, you said A. Why did you say A?
Because again, I wasn't sure what the answer is.
You guessed, you mean.
Yes.
Okay. Maureen, how did you solve number 7? How can you solve number 7?
I don't know. I put B for my answer.
Let me see if I can do it
You
now.
put 1?
B.
You put B for your answer. Well, it's not B. Tell me, how would you solve it, Maureen? Remember, I gave you something that you could use as a clue when you're solving something like this. What was the clue? You remember, Mercedes?
No. You give us a clue. I don't know.
I gave you a clue.
Oh,
You remember, Mercedes, the clue I gave you?
Multiply denominator with
No, I
that's
gave you a clue. When you're trying to simplify here, you look at the expression where you
okay.
see that square root, you see a 3, right?
Yes.
Well, you think about it. You're looking at your other number. What can I do with my square root of 12 to get a square root of 3? What are factors of 12 that has a 3 as part of it?
2.
12, 3 times 2 is 6.
Oh. Oh, 4.
Yeah, 4. See, 12 equals 4 by 3. That was the hint I gave you. So you have the 3 here under the
Uh-huh.
radical, right?
uh,
Now look at your 12. Think of what factors will give you a 3. 4 times 3. Now you take that square root of 12. Let's just take the square root of 12, and we can factor that into 2 radicals, right? So square root of 12, let's just put that there. Now, Mercedes, what does that factor in the 2 radicals? What would they be?
6.
2
6.
radicals. What would the 2
Uh,
radicals? Square root of 12 would be the multiplication of
uh,
2 radicals. What 2
that's 3
radicals
and 4.
multiply? 3 and 4. That's right. So you have 4. Let's put that there. 4. And we have 3. All right. Now, what's the square root of 4, Mercedes?
2.
2. So that's 2. And that's square root of 3. Now we have 2 times square root of 3 plus 3 times square root of 3. So let me just copy that here. And Mercedes, you'll tell me the answer. So let me just put the square root. Okay. Okay, I'll put this all on the next screen. Okay, so the square root of 12 is equal to 2 times square root of 3. So let's just put that there. 2 times the square root of 3. And we're adding that to 3 times the square root of 3. And what's that equal to, Mercedes?
Add it to the that would be
What's that equal to?
radicand 3, right?
2 times the square root of 3 plus 3 times the square root of 3. They both are coefficients of the same radical. So I can add them. So what would be the answer, Mercedes?
So you say 2 times can I repeat this by your
2
sentence?
to the 3. That's 3.
2 times the square root of 3 plus 3 times the square root of 3. Same radical. That means I can add the coefficients. What are they?
Oh, 2 and 3.
That's right. What's that equal to, Mercedes?
5.
5. So you'd have 5 times the square root of 3. That's your answer.
C.
That's right. Answer C. Mercedes, you see that?
What
Answer C.
answer did I give?
You gave, let's see, 7. You said A.
Okay.
All right. But remember, I gave you the clue there. And I said, when you see an expression and you see a radical, think about that one that needs to be factored and use that 3. And 3 times 4 is 12. So now you have your factors of square root of 12, square root of 4, and square root of 3, and square root of 4, perfect square root, 2. Now the square root of 12 becomes 2 times square root of 3 plus 3 times square root, 2 times square root of 3, because square root of 4 is 2. So you can add them because they all in front of the same radical. So if you can add 2x and 3x to get 5x, you can add 2 times square root of 3 plus 3 times square root of 3 to get 5 times square root of 3. Questions?
Thank you.
Questions, Maureen?
No, Miss Barbara.
So you can do one on your own, right?
Look at that.
I'm still going to review the recording with this miss.
Okay. But I want to give you one to do. Let me just take this.
I'm not going to do it. This.
No,
Still
you can do it. Let me put one here. I want you to practice on this one. This is let's see, 18. Okay, plus 2. And mental math, you can tell me the answer. What's the answer?
The answer would be, let me see now. 18.
That's not really a good one. Let me give you. I want something that has a perfect square root. This one won't have. Let's see. Let's see, 20.
Oh, I would have to find the square root of 18, miss.
Okay. No, it's not a perfect square root. Let's see. See, I'm trying to get a 3, but I want something that has a perfect square root. Okay, so let's take, let's see, 15, 16, 21. Let's see, 4. 64, let's see. Okay, I'll just take this one. There we go. What would be the answer?
The answer would be, let's see.
This is mental math one I gave you. What would be the answer? You could do this one, mental math, right?
Okay, 2 and what is sign again? Radical 3 upon 3.
Square root of 9 plus 2 times square root of 3. What is that equal to?
Square
That
root of
is
3 and 6.
What's the answer, Maureen?
Square root of 3 and 6.
What?
The square root of 9, which is 3. Right?
Yeah.
Okay. And 3 and 2 is 5. So the square root of 3 and 5.
No, but 3 is not times the square root of 3.
so 2 the square root of 3 upon 3 is wrong. Upon square root of 3 is wrong, miss.
What would it be?
2 square root of 3 upon square root of 3. Like the 2's and the sign and 3, and you put the cross under and put square root of 3 on the over under it.
What are you saying, Mercedes?
2 square root of 3 over square root of 3.
No. This is not a rationalized now. This is simplification. You don't see a radical in a denominator here, right?
3 and 9 is 3. That could be 3.
Square root of 9 is a 3.
Yeah.
Right?
And then it be square, that would be 3, 2 radical 2 square root 3.
What are you doing with the square root of 3?
That's definitely like that.
It will be 3.
Square root.
No, 3 plus
Square root.
square root of 1.
3, 2 to the square root 3.
3 what? What goes
That
after the plus?
The 2
2
square root 3.
square root of 3. That's it. That's the answer.
Oh,
Miss.
Yes.
That's what I was trying to say, but I was putting it a different way.
No,
I
you
was
said over, but see, there's
yeah,
nothing to put here in the denominator, Mouse Lady. You
I'm
were trying
trying
to
to
make it rationalize.
because I thought that's all you read the answer.
No, no, no. This is not a rationalization now. I don't have a fraction here with a radical in the denominator.
Oh, that's what I'm mixing.
Right? Then you're getting them mixed up. I said just simplify this. So you square root of 9 is a 3, and this is plus 2 times the square root of 3. That's it.
Okay, okay, plus 2 times the
Can't
square
you
root of
can't
3
do
make
it. You
9.
can't do anything else with this because these are in their simplest form. I
Okay.
can't add the 3 to the 2 because unless I had a square root of 3 following the 3, I can't add, right? You can't add the number to a radical. It has to be a coefficient of a radical, and they have to be the same radical. In other words, I can add 3 times square root of 3 to 2 times square root of 3 and get 5 times square root of 3.
So that is how it should be written out. 3 plus
2
2
times
times
square root of
2
3.
plus
That would
3.
be it.
Okay.
That would be
That same those same 3 figures. That's what I have in my head, but I think I was just giving it the wrong position.
yeah, you may have had them in your head. You should have written them down and then told me what you had written down, Mercedes. Not just in your head. Write them down and then tell me what you have, because you were saying over and there's no fraction here, right?
Okay.
Okay. All right. Let me take another one. I want you to try another one. Okay, take this one. Let's see. Copy this over because I want to give you another one because I want you to practice some of. Now this is just simplification. This is not rationalizing. Okay, now this one is let's see, 2 times square root of 64 plus let's see, see 20, 24 plus 8 times square root of 6. Okay, I want you to solve that one. Simplify. It's not rationalizing. Simplify that expression. Okay, so let me just put that all on another screen and you tell me what to do first. I want to simplify it. That means I want to probably get it in a format where I have my expressions with the same radical. Anybody suggest what I'll do first?
Um,
square root of 2 radical square root of 24 first.
What's your hint here, Maureen? What do you want to make your radicals the same? What radical do you want to make the same here? Say it, Mercedes.
2 and 6 are
Oh
2.
no, I said radical. You're giving me too many
Okay.
numbers. You give me
Let
a
me tell you,
radical, you give me just square root of something. So what is that something? Square root of what?
Square root of 6.
Square root of 6. Mercedes, you're absolutely right. I want to get both my expressions to have a square root of 6. So one already has the square root of 6. Now you work on the 24. What are factors of 24?
Factor 24, 1 is 4.
What are factors of 24? Give me
12.
give me two numbers.
4 and 6.
4 times 6. That's the more logical one. Why? Because 4 has a perfect square root.
Yeah.
So now take your square root of 24 and factor that into square root of 4 and square root of 6. And tell me what you get. I'll copy this. Right. And let's just take that square root of 24. And that factors into what, Mercedes? Two radicals. What would they be?
It will be 4 and 6.
That's it. Very good. Be 4 and 6. Okay. So let's put our 4 here. And let's put our 6. All right. Good. Good start. Now you can finish it. And what's that equal to? What's the square root of 4?
2.
2. So that would be 2. And then the square root of 6, we leave it just as it is, right? Now you've got square root of 6, same as here. So what's your answer? I won't put it there. So now you can tell me the answer. What's the answer?
I'm not even sure yet.
Maureen, you know?
Yeah.
What? What's the answer, Maureen? I don't hear you.
8 plus the square root of 2 and 6.
No, you have both of your expressions with square root of 6, so you can add them. So what would be your answer?
Oh, we can add them. So is
Square
the
root of
answer 8?
What would be the answer, Mercedes?
8?
You throwing away your other numbers?
Oh, Lord.
2 times square root of 24. Let me just take that by itself, right? Let me just put that here. Well, we said square root of 24 was 2 times the square root of 6. So square root of 24 would be equal to 2, because we have a 2 already there, right? Times 2 times square root of 6 that we have right here.
Okay.
So let's just copy that there. Okay. That's in parentheses. Okay. And what is that equal to, Mercedes? What's 2 times the square root of 6? What is that equal to?
Would that be 12?
Are you getting 12?
Because you said 2 times the square root of 6.
No,
Oh.
you can't multiply square root by the number. Remember, I just told you, you can't
Oh.
multiply square root times a rational number. You can only multiply square root times square root, but you can multiply rational number times rational number. So you can multiply 2 times 2 and you get a 4, right?
Okay.
And then square root of 6. Let's put that there. So 2 times square root of 24 is 4 times square root of 6. So now if I take this, let me just copy it again. You can see the answer. What's the answer, Maureen?
4 square root of 6.
I'm adding. What's the answer? 2 times the square root of 24 is 4 times the square root of 6. So that would be equal to
14.
no 4 and 8.
12.
12. That's right. So that would be 4 times the square root of 6. Let's just copy that. We just figured that. All right. And that would be plus the 8 times the square root of 6 that we had in our original problem. 8. Let's put the 8. Now we could just add those coefficients. What are they, Mercedes? What is that equal to?
That would equal to what, 2?
No, Maureen just told me, right? What is it, Maureen?
12.
12. Just add the coefficients. I'll say these 4 plus 8.
Oh, I see it.
And that's 12 times square root of 6. That's your answer.
Is there a shorter way, miss?
Well, the shorter way is Mr. Math. Recognizing that the 24, you need a 6, a square root of 6, right? And if you did that right up front, you recognize, well, I've got a square root of 6 here. I need to get me a square root of 6 here. So knowing your factors, what number times 6 give 24? 4. Perfect square root, 2. 2 times 2 is 4. So 4 times square root of 6 plus 8 times square root of 6 is 12. See, once you know these factors, you can do the mental math. Your clue here was the square root of 6. So now you look at your 24. 6 and what else are factors of 24? The what else is a 4. Got it?
I'm still trying. I never
Well,
do math like this before.
start here with the 6. Mercedes, what
It's
number times 6 give 24?
2.
6 times 2 is 12.
Oh, sorry. What you say? What's time
What
number?
number times 6 gives 24?
4, 6 is 24.
Right. So that means the square root of 24 is the square root of 4 times square root of 6. Square root of 4 is a perfect square root. You know that's a 2. So you have 2 times 2 is 4. 4 times square root of 6 plus 8 times square root of 6 gives you 12 times square root of 6. Got it?
Still have to look over it again. It's
Yeah,
really
yeah. But I'm saying your clue is right here at
so
square
sad.
root of 6. You say, I've got a square root of 6 here. Well, let me see if I can get a square root of 6 here. Okay. And I can, because 6 times 4 is 24. So just like you can say 6 times 4 is 24, you can say square root of 24 is square root of 4 times square root of 6. And that's what we have right here. And the square root of 4, perfect square root, a 2. So you have 2 times square root of 6. But you had a 2 already here, right? In front of the square root of 24. That's why you had to multiply 2 times 2 to get 4 times square root of 6. Now you have them both square root of 6 with coefficients that are 4 and 8, and then you can add them.
Oh,
Got it?
oh, if you bring it down to the bottom and then you add
Right here.
yeah,
You have
right there.
square root of 6, square root of 6. Now you
Yeah.
can add those coefficients, 4 and 8. Just like we've been doing with
12. Okay.
variables. Like if you had a 4x and an 8x, you get 12x, right?
Okay.
Only thing, you have some radicals here, but they work the same. Coefficients you add just like you do when you was dealing with variables.
Okay.
Got it? No different, except it's a radical.
Because in
Question.
my head, I'm used to the other way, multiply and whatever. That's why.
What is it, Mercedes?
Because in my head, I'm so used to the other terms of multiplication. So it means I go right back to the old way.
What do you mean the old terms?
Instead of doing the radical as you're teaching us, I keep slip back into the old way, or we do it. Because you keep on saying, don't, you can multiply the radical with what radical and get back a radicand. So I'm saying I'm every time my mind slip back to the old ways, which is not that way of teaching this new type.
No, it's not new.
Is that new?
No, remember when you remember when we did coefficients with in expressions and you added the coefficients?
Yeah.
This is no different. It's no different. I mean, there's no difference. Like if I said here, okay, 4y plus 9y. What's that equal to, Mercedes?
That is equal to 13. And why?
That's right. That's no different. That's no different than if you said 4 times, let me put this here, okay. 4 times square root of, let me just put a radical here. 4 times square root of 3 plus 2, let me put square root of 3. Now, what's that equal to, Mercedes?
4 times the radical 3
4
plus
times square root of 3 plus 2 times square root of 3. What's that equal to?
6 the
6
radical 3.
times, that's it. Same thing. That's what I'm saying. It's no different.
Oh,
You follow? I don't want you to think this is so, this is something that's foreign. It's not. It's just you're dealing with radicals instead of the variables, but it's the same thing. You add the coefficients.
okay.
Like you couldn't add a 4y and a 4x, right? Like you can't add a 4 times square root of 3 plus 5 times square root of 2 because they're not the same. But if they were the same radicals, you can add the coefficients. Just like same variable, add the coefficients. No different.
Okay.
You got it?
Yes.
So the key for your simplification is try to get radicals the same so you could add or subtract or whatever,
Okay. You
right?
have 4 radical 3 plus 2 radical 3, and then you add them, you get 6
That's
radical
right. Just add the coefficients and keep the radical. Just like you added the coefficients for your variable y and you just kept the y.
y. Okay.
Yeah.
Okay.
And the same for subtraction. If this was 9y minus 4y, you get 5y. If it was 9 square root of 3 minus 2 square root of 3, you get 7 square root of 3. Same
Okay.
thing, no different. You got it?
Yes, ma'am.
Yeah, that's what I want you to realize, and you too, Maureen, is that when you're dealing with these radicals, this is the same rules we've already always had, right? Same
Yeah.
rules. We're just getting them under the same radical, and then we can do our operations. Now, this is for adding and subtracting. Now, when you get to multiplication divisions, they don't really have to be the same. Okay, that's a different operation. But addition, subtraction, you want the same radicals. Okay. Questions? All
No,
right,
sir.
let's look at probability. And number 8, okay. Mercedes, you had number 8 correct. Very good. All right. Now, tell me how you did number 8. Maureen, let's see what Maureen has. Maureen, read number 8 and tell me the answer.
A drawing cards from a 52 deck. Any single card has an equal chance of being drawn. What is the probability of drawing a jack of diamonds?
What would you say the probability possible over total?
That's a 1/52.
1 over 52. That's correct because there's only one jack in the deck, right?
Exactly. That's what I think about Mister. I think he's only a jack in there, so it can't be no
There's only
more.
one jack of diamonds. There are 4
Yeah,
jacks, but there's only one jack
a
of
jack of diamonds.
diamonds, right? So Mercedes, you had that one correct. That's very good. You had answer, what, A?
Yes, miss.
Right? Okay.
What 7 was what answer again, miss?
7?
What answer again? C?
7 was C.
Oh, yes, thank you.
C. Okay. So probability, possible over total. Possible, there's only one jack of diamonds. Total, 52 cards in the deck. Probability 1 over 52. Okay, now that was number 8. Now, let's see, Mercedes. Number 9, you had B. Let's see, Maureen, you want to help Mercedes out? She had B and it's not B. Read number 9, Maureen. Tell me the answer.
Let me see if it's in my head, if it's
In a
this
game
answer.
of playing spin a spinner, the spinner is shown below. What is the probability of spinning a number?
Possible over total. Probability is possible over total. Remember? So how many odd numbers are there? Probability, we said
3.
probability
3,
of
miss.
Maureen I'm talking to.
Oh,
It's
sorry.
3.
Maureen is, okay, so we say odd, probability of an odd number. So how many odd numbers are there, Maureen?
3.
3. And what are they?
1, 3, and 5.
That's right. And what's the possible? What's the total?
6.
How many numbers on the spinner, Maureen?
6.
That's right, 6. So let's just back up. Okay. And 3 over 6 is equal to what, Maureen? Simplified.
1/2.
1/2. That's right. So this would be 3 over 6. And that's equal to 1/2. Now, what answers that?
B.
D is in dog. Okay. Okay, so that's equal to,
Miss, why 1 off? I don't get it.
what's half of 6, Mercedes?
I know half of 6 is 2.
Half of
Sorry,
6
half of
is
6
what?
is 3. I know that. Sorry. 3, I mean 3.
So that's how you get a half. You just told me half of 6 is, you said half of 6 is 3,
So
right?
you're saying because there are 3 odd numbers and 3 equal numbers. You gotta say what's the possible
Possible, how many possible odd numbers are there, Mercedes?
3,
3. And what's the total of all the numbers?
6.
6. That's how you got 3 over 6. Or 1 over 2.
Oh boy.
You got it?
That's I'm looking at it, all right. I'm saying there's six colors. So I'm saying possibility of drawing only one odd number. That's why I say 1 over 6.
But how many odd numbers are there, Mercedes?
There are 3
So why did you say 1? And there are 3.
because when the wheel turns and it stops, only one number can go on. The pointer.
Yeah, but the probability of an odd number is the number of odd numbers. That's possible.
Oh,
There's a possibility of getting
and
1, 3, or 5. That's 3 different odd numbers,
okay,
correct?
got you,
You
got
got
you.
me?
Yes,
Possible, 3.
yes.
Total, 6. Got it?
So you have to simplify it.
Yeah, and you have to simplify it because you don't have a
First,
3 over
first you
6
have to
here.
say the odd numbers are 3/6 because it's 6 places.
That's right. Possible over
And
total,
then
3 over 6. So your answer, once you simplify it, you get D, 1 over 2. What's the possibility of getting a 3 on the same spinner, Mercedes?
3. You're talking about the odd number still?
I'm just saying the number 3. What's
Okay.
the possibility of getting the number 3?
1 to 6.
That's it, 1 to 6, because there's only 1 3 in the total of 6.
Okay.
Okay, so if I
So
gave
when
you just a
is
single number, then it would be 1 to 6.
okay, but because you say odd numbers and there are 3 odd numbers,
Right,
becomes 3 to 6.
that's right.
Yeah. And why that's I'm still asking the question. Why it's simple down to 1/2?
Let me ask you again, what's half of 6?
It's 3, but that's not the question.
Yeah, but if half of 6 is 3, then 3 over 6 is 1/2.
Yeah, but why
Or if
one
you did, well, Mercedes, if you divide 3 into 3, you get what?
one?
And
One, I
3
know
into
that.
6,
It's 2.
isn't that 1/2?
Yes.
So
But
what?
I'm comparing I'm saying one that is telling me is one odd number over 2. I'm looking at the masses a different way. I says because it is 3 odd numbers over 6. I understand that.
Right?
When you break it down to 1.5, 1/2.
Well, the probability of getting an odd number is 50%, which is 1/2. You understand it from a percent?
Oh, okay.
Because remember, percents can be decimals, fractions, or percents, or
Okay, because
ratios.
the 3 odd numbers are really half of the
That's
whole.
half of the numbers, right?
Okay, got you.
Yeah, or 50%. So 3 over 6 is half of the numbers, and it simplifies to 1/2. 50% of the numbers are odd, 50% are even. You got it?
Yes, ma'am.
Now, there's the 1/2 clear, Mercedes?
Yes, Miss Barbara.
Okay, so it's 50%, 1/2, 3/6. And the reason we put the 1/2 because there's no 3/6 there. The answer assumes you simplified it to its lowest number, lowest fraction, right?
Okay.
Okay. That's clear, Mercedes? I want to leave until
Yes,
you
yes,
understand.
yes, it's clear. Thank
Okay.
you.
All right. Now, dependent event. Okay, Maureen, read these and tell me which one is dependent.
Okay.
Which is the dependent event.
Riding the bike and watching a concert, winning the lotto after buying 10 tickets, taking an Uber ride, and getting a free meal at your favorite restaurant or flipping a coin 6 times.
Which of these is a dependent event?
I had to see.
Why?
I don't know. I said taking a ride to get a free meal is independent.
Yeah, that's what I think too.
I ain't got the pay.
How is taking the Uber ride dependent upon getting a free meal?
Because the free ride is offered. So if you want to get the free, if you want to get the meal, you gotta take the ride.
But they didn't tell you that.
That's why I look at it, Miss.
But no, you can't look at it. You have to look at what they tell you.
taking an Uber
Those
ride.
are independent events, unless I told you that you'll get a free meal from taking the Uber ride. A free meal comes with taking the Uber ride, then it's dependent. But I didn't tell you that.
You say which of these is a dependent event?
In other words, taking an Uber ride is not dependent upon getting a free meal.
Or because you can take another ride from different from Uber to get the meal.
No, no. The free meal is not even related to taking a ride.
Oh,
You gotta look at what I gave you. I didn't say that you got the free meal from taking a ride. I
Yeah,
say
right, if I
taking a
spend a lot.
ride and getting a free meal. Those are independent events. One does not depend on the other. And the only way it would depend is if I gave you some more information, but I didn't.
But the answer got to be B then.
What's the answer?
B,
Say it again.
B as a boy.
B, that's the answer. Because the more tickets you buy, the better your chance at winning the lottery.
oh no.
That's your dependent event. Your winning the lottery is dependent upon the number of tickets you buy, because your probability of winning increases with the number of tickets you buy.
Missy, notice that I gave you
You gave me two answers,
A
Melcy.
and C
Yeah,
because
you gave me A and C. Both of those are independent.
oh no.
Riding a bike is independent of watching a concert.
I think I mixed up one of my answers with another answer. I'm giving you two different answers, two different
Yeah,
questions.
it was only one answer. So which of these is a dependent event? One answer, and that's B. Everything else there is independent. Like if you flip a coin 6 times, you get ahead once. The next time you flip is independent of whether you get ahead. That second flip is independent of what you got on the first one. All right.
Okay.
It's still, the probability is still 1/2 or 50%. And everything else here, ride the bike, I said, and watching a concert, independent. Riding a bike does not depend upon you watching a concert. Taking a ride doesn't depend upon you getting a free meal. All right. So the
All right.
only one
Miss,
that's
let's go back
dependent
to
is
number.
B.
Miss, can we just look at number C again? You said taking an override and getting a free meal at your favorite restaurant.
Well, think
This is
about an Uber ride. Now, you could be taking an Uber ride to go to a park, right? It may not even be related to going to a restaurant for a meal. So they're independent. You got it?
Oh yeah, it's independent because I ordered the override. I got it.
Yeah, they're not dependent. I mean, they separate events, not
You're
dependent
free to
upon
do
each
what you
other.
want.
Yeah, you
Flip
could. You don't even need a ride to get a free meal. You may just be getting a free meal from coupons you had.
yeah.
So
And
they're not dependent on each other. Okay,
flipping a coin is also
independent.
independent.
Yeah, the second flip has no relation to the. It's not dependent upon your first flip. Your probability is still 50% because you have a head and a tail. Right?
So Miss, what make winning the lottery after buying
Dependent event. Because the more tickets you buy, you're increasing your chances of winning.
So so you're buying ticket that you're depending on buying ticket to get a chance to win.
No. The more tickets you buy, the more chances you have to win.
So Miss, listen to what I say, Miss.
Go ahead.
I'm saying so the more tickets you buy, no, you depend on winning by buying more tickets. You're dependent on winning is to keep on buying more tickets. I just said it another way. You're dependent on winning, right? So that's the reason you keep on buying more ticket.
No, you want to increase your chances of winning.
Oh, you just say it the same way. It's a different
Yeah,
word.
yeah, you increasing your chances of winning by buying more tickets.
Yeah.
Yeah. It's like I was some years ago, there was a raffle ticket for a cruise
Okay.
and they were $10. And I was with my friend from work and I said, I'm going to buy 2 tickets because I think I'll have a better chance of winning.
Oh.
So I bought 2 tickets. He bought 1 ticket. We bought our tickets at the same time. So really our numbers was like I bought like maybe 50, 51 and he bought 52. When they pulled the winning ticket, I won. And
Oh.
I said to him, had you put another $10 in there, you would have had that winning ticket.
Oh.
Well, maybe he would have had the winning ticket. I don't know. But anyway, I reasoned that my probability of winning increased by me buying 2 tickets versus 1 ticket. Because say there are 200 people in the room and everybody buys a ticket, right?
Yes.
So you out of 100 people, everybody back is like a 1 over 200. But if I buy 2, I've got 2 over 100.
Yeah. Yes. You have a better
Right?
chance.
So I increased my chances of winning by buying 2 tickets, and then I won the
Oh,
cruise.
because I remember they had a competition in Jamaica, and the lady says one person said I won because I sent in more envelope. The lady says no. When we count your envelope, somebody sent in 300. When you send in 300 of the right answer. When you send in 250, so you have to give that person the win.
Okay, that person sent more
And
than
I
that.
didn't know. That's the time I says, oh. That's how they get the winner because you keep on sending the same answer, but like
Uh-huh.
600 times.
Yeah, well, the chances of them pulling your number, if you send it 600 times versus somebody sending 6 times, is certainly increased.
Exactly.
Because maybe you've got 600 out of 1,000, say, that sent in. The other person only have 6 out of 1,000. What probability is bigger? The 600.
None.
Yeah,
One.
600. So it's dependent upon the number of times they sent in the answer.
Oh, yes, that's true.
Okay. So that's why winning the lottery after buying the ticket is dependent because the more tickets you buy, you're increasing the chances of winning. All right. Questions on dependent and independent events. Now
None.
remember now when you have what did I tell you when you're drawing something and you're replacing it? If you don't replace it, it's a dependent event because now you have less items once you take them out and don't put anything back, right? So
Okay.
your
Yeah.
total has changed. So that's a dependent event when that happens. Okay. All right,
Yeah.
let's look at number 11. Okay. Maureen, read number 11 and tell me the answer.
There are 15 colored chips in a bag. 8 are green and 7 are white. 5 white chips are removed. What is the probability that the next chip selected will be a
It
green?
should be A-R-E. See, that's an error.
I
It
know.
should be R white. I'm making it correct now. Okay. 7 R white. Okay. Now, Maureen, how would you solve this? You've got 15 in the bag. Let's underline the 15. Okay. 8 are green and 7 are white. So
Right,
let's just
yeah.
put that there. All right.
100%.
5 white chips are removed. So that means we took 5 white chips out. We did not put them back, right?
You
No.
didn't put them back, right?
You didn't put them back. So,
Right.
Maureen, what's the answer?
Well, that's like, okay, take a 5.
You took out 5. How many are left?
10.
10. Okay. 15 minus 5 equal 10 chips left in the bag. All right. So 10 chips left in the bag. Now you took 5 out. So what do you have left? You have 10 chips left in the bag. How many are white, Mercedes?
How many? There were 5 whites.
How many are in the bag? Once you took the 5 out, how many white chips are left?
There are 5 white chips left.
No, you
And
took 5 out. So how many are left? You started with 7.
hold a minute. Let me go back there. So you're talking. It says after you take out the first 5 chips, you're talking what left?
How many white chips are
Whites.
left?
5 white chips.
We took out. How many did I start with? How many did I have out of the 15? How many were white?
There were, and 7 are white. 7.
7. So how many white are left?
2.
Okay, how
2.
many green are left?
There are 8 greens left.
Okay, so what's the percent then? Of 10 chips, 8 green, what's the percent?
That's um that will be 10% of what?
10 chips left in the bag, and of that 10, 8 chips are green and 2 chips are white. So what percent? So what's the probability of the next chip being a green?
I would say maybe 80%.
That's it. Very good.
Uh-huh.
80%. That's
Oh,
right.
yeah.
Possible. You have 8.
Yeah, get that right. So you get
Total
my same
is
thing.
10, right? Maureen, you got it?
Yeah.
That's 80%.
Well, I gain a point, miss.
Mercedes,
Get same points
okay.
for that.
You didn't give an answer for that one.
No, miss, because miss, I finished the work this morning sleeping. And I look, I said, oh my God. You know what? Let me put the question sign. When she's doing it, I think I will work at that time.
Yeah, I thought
I just
you would
did it.
get this one.
I
Because
just did it.
15, you took 5 out, that left 10. Of that 10, and since you took out white, you only have 2 white left. So 8 are green, you have all your green left. So possible 8 over total 10, 80%. And your answer is B. Answer B. Got it?
Yes, miss.
Okay. Now let's go to 12. And 12,
Oh, it's a top one, miss.
yeah, well, there's something I hadn't told you about this. I thought maybe you'd be able to figure it
I
out.
didn't know. I don't know how to do it.
Okay, well, let me just say something to you. When you add up all your probabilities for an event, they should add up to either 100% or they could add up to 1, right? So you add these, the O type, A type, B type, and subtract from 1. Okay, so that's how you would solve this one. So the AB
Oh,
type
Lord.
So do that and tell me what you get. The AB type would be equal to the O type 0.45
AB
plus the A type 0.440 plus the B type, that would be 0.10.11. And all of this would be subtracted from 1. So this would be 1 minus the sum of these. So do those, tell me what you get. Let's see, this is decimal. You can do it on your calculator. So the AB type is 1, since they gave them to you as decimals, minus the sum of the O type, the A type, and the B type. So that would be 1 minus what?
So, finish that, Mercy.
Got the
Um,
answer?
wait
That
one
was,
sec.
I was asking Mercy if she finished.
1
One
minus
sec.
what?
Wait for me.
Okay. When you
Okay.
add those up, Mercedes, what did you get?
I
0.45, 0.4, 0.11. Mental math.
I got 1.06.
No, 0.45 plus 0.40 plus 1, 1. What
Miss
is
I
that equal to?
wait a minute. Miss I put 1 minus 0.45. I put it wrong.
Yeah, but when you add these up, what do you get? When you add 0.45 plus 0.40
Oh, I
plus,
let me do it over. I think I put in
you're putting these blood types here.
oh
0.45,
uh, okay.
0.40, 0.11.
The wrong numbers. Sorry, let me just quickly do this over. Plus
And you add those up, subtract them from 1. What is that total of O plus A plus B type? B types. What are they equal to?
you said I should subtract 1 from it.
No, what's the total? What did you get as a total here?
0.96.
Okay, now subtract that from 1. What do you get?
Previous 0.95. I don't know mental.
0.96.
Hold up. All right, let me do
This
that.
is 1.00. What's that equal to? 0. What?
I can mix up. You said that's a subtract what, miss?
Subtract the total 0.96 from 1. 1 is all the types. And if they had given you percents, we would have used 100.
I got what the sign is? Negative
You don't get
0.
a negative. You're subtracting 0.96 from 1.
0.96 from 1. Oh,
Yeah.
I wrote it in
What's
wrong.
that equal to?
0.96 from 1 is equal. I give it the same answer.
What are you getting?
I'm getting 0.04.
That's the answer. So the AB type is 04. So the probability of the AB type is 0.04. Okay. So probability of AB is equal to 0.04. So this would be 0.04. There's your answer.
So all I need was to do is to add up
Yeah,
0.
add up the O type, the A type, and the B type, and subtract it from 1. That gives you the missing one, because these all add up to 1, or say 100%. Because this could have been 45%, 40%, 11%. Then the answer here would have been 4%.
The reason why You use one miss. Is it because one it says missing?
No. The total of all probabilities is equal to 1 or
Oh,
100%,
okay, got you.
regardless of what we're looking at. It's like, well, if you like heads or tails, heads is 50, tails are 50, they add up to 100%,
Okay.
or one half adds up to one half plus one half. Now we go to the B answer, the B probability. The probability of getting O or B is probability of O plus probability of B. So you just go pull out the O, 0.45, and the B is 0.11, and add those up and you get 0.57. All right, so that would be the answer for B. Questions?
47. I
0.45.
don't. Okay.
The probability of getting one type or the other is an addition problem. So you just take the probability of the type plus the probability of the other type, add them up. That gives you the probability of one type or the other.
I'm sure this last part of it. Look at it.
Questions? Well, they gave us the probabilities up here. So we just had to plug those into probabilities and add them.
So if you add 45 and 11,
Yes. Oh,
that's
56. I'm sorry, you're right. 56. I just saw that. Yeah. There we go. 56. So 0.45 plus 1 gives you 0.56.
So 56 is the probability that O
Yeah.
or B is
That
blood.
a random chose American can donate blood to Maria uh, if they have types O and B.
Especially O miss.
Mhm. O and B or ORB. She can safely receive blood transfusions from people with blood types O and B. So O and B, well, she can't receive them both at the same time. That's why I said O or B. So you it's an addition. So you add the probability of the O plus the probability of the B, and you get the 0.56. This one was I put in to see if you would realize that the missing one will increase the total of all types to 1, and you would have added up and subtracted. So now you know that your total probability is 1, or it could be 100%. All right.
Mrs. It's true that I don't know if you know that they said type O blood is a top blood. You can save anyone life.
Oh, the O type.
Yes,
Oh, I don't know.
heard about it.
That,
Um,
that O, any type person can use O.
what so I heard. I must check it out
Oh, I
online.
don't know.
Yeah,
That's a
but
good research thing.
and anybody.
Maureen, find out. You and Mercedes, and tell us on Thursday
yeah.
Okay.
What you
which
say, Mercedes?
which type of
ORB
blood can be used by any type
blood. You can
of
save any.
person.
Yeah.
Do you know your blood type, Mercedes?
They told me it's O. And
What is yours, Maureen?
Oh,
Mine is B.
and I when I came here, I was depressed one of the time, and I went to the doctor, and they they take a little of my blood and test it first, and then the doctor came back with 7 vial. And I'm there lying on the bed looking at him, and the other doctor now came in to me and says, "Don't take any more for blood. That is enough." After I reached 5, full 5 already, and I said to her friend, I said, "Why on earth?" It made me scared. Why on earth is it taking so much of my blood? So you have a rare blood that they're looking for.
Oh, really?
You say you have a rare blood, and that's the reason why it's taking so much. It's not because of anything bad. It's just they're looking for that blood that can save life. That's really good.
Okay.
That's
What
when
you
I
say, Mercy? You say
oh
which type?
She says, oh,
Oh,
yeah, yeah. Check that out. Let me know.
okay.
really take it
Which
off
type?
too.
Okay.
I've heard people say there's a
You
blood
want to
type
know
that can
if
be
you
used.
fully want to know if all could give to anybody that is A and B?
No, we want to find out what blood type
Can
can be
go to
used for
anyone.
any blood
But
types. In other words, you have
Oh,
a type. There's a type that Mercedes is saying you can use regardless of your type, whether you A B, or whatever. Or
H
O.
type.
There's a type of blood she said can be used for any types for transfusion.
Uh,
All right. So that's one of your homework assignments. To research that and let us know. All right. Now I wanted to look at, let's see, new share. Uh okay, I just wanted to look at, just review the notation. Do you see the scientific notation rules?
can you make it a little bigger, Miss, please, because of my phone?
Let's see. Right, let's make that
That's
you
okay.
see it now? Okay.
Yes, thank you.
Okay, so I'm just reviewing some scientific notation rules. They're written in the form of A times 10 to the B, right? A is a number between 1 and 10. Just remember that. That's the first part of the scientific notation. Okay. And okay, the number you raise it to, well, if you say times 10 to the X, X is the number of places you need to move the decimal point. Okay. And if it's a negative, you're moving it to what? The right. And if it's positive, you're moving it to the left. Okay. It's right here. If it's negative, the decimal point must be moved that number of spaces to the left. If it's positive, the decimal point must move that number of spaces to the right. Now, those are some notation rules to make sure you get the correct scientific notation. Like if you had 100, you're moving it to the left between the 1 and the first 0, and that's 1 times 10 to the second. Whereas if you had 0.001, you're moving that to the right 3 places, and that's a -3. Okay. Now, the exponent rules, you should remember those. I gave you those before. Remember those for the scientific notation. For addition and subtraction, your exponents must be the same. For multiplication, you add the exponents. For division, you subtract the exponent of the denominator from the exponent of the numerator. So I'll be sending you this in the session today. Now, the next homework will not have probabilities. I will only give you scientific notation and simplification of radicals and rationalization of radicals. And we'll do some more probabilities on Thursday. So homework, scientific notation, uh, simplification of radicals, and rationalization of radicals. All right.
yeah.
And hopefully you'll be able to get that part of our lesson,
Mhm.
done. And then we will look at probabilities. We'll do
Okay.
that separate on Thursday. After we look at our homework that will be on scientific notation, simplification of radicals, and rationalization of radicals. Any questions on anything we've gone over?
So,
Promise.
Okay. All right. So thanks for joining. I will see you. Well, I'll see you later, 3:30.
yeah.
30
4:30.
I'm sorry, 4:30, 4:30 to 6:30.
Why
So I'll
couldn't it
see you
be
at 4:30.
5:30?
What is it, Mercedes?
Why couldn't it be 5:30?
Oh, it's 4:30.
No, I'm just asking why couldn't it be?
You can come in at 5:30 if you want to.
Well, it's 4:30 to 6:30. Those are the hours.
Because I want to catch a little nap. Guess why?
No,
Well, you can
well,
come in at
it's
5:30, no problem.
4:30, 6:30. First part, we'll be going over our homework, and we had a lot of homework. Okay, so
Yes.
very important that we get that done. All right.
Okay, miss.